So I've been teaching ML classes for artists for almost 2 years now. And a pretty common behavior I see is we start using Runway. Everyone gets really excited about Runway. And then maybe 2, 3 weeks into the class or just into using Runway, you're sort of like, I feel like I've sort of expanded or done everything that I can inside Runway. So what's next for most folks? So my step for most folks next is to start to use Colab. So I've been teaching Colab for probably a year plus now, and I've sort of learned that it is a big leap to go from Runway to Colab. So this lecture or this video is really about me trying to explain Colab. I've tried this a couple different times. I think I've maybe finally hit on the best way to describe it for folks. So I'm just going to walk through a little bit of what Colab is, how it differs from Runway, do some demos, and then also try to slowly ease you into using Colab. So Colab feels very, very different than pretty much any other tool you'll probably use. Even if you're a command line person, like Colab will still feel a little different than someone who can comfortably use the command line. So in my experience, you sort of have to take a couple weeks of just sort of maybe struggling a little bit with Colab to understand its benefits and why it's powerful. So bear with me as I try to explain this. My hope is that this will work better for you and sort of give you every little bit of thing you need to get over that hump of using Colab. So let's start with just what is Colab. So Colab, first of all, is a tool by Google. Google has a very controversial view inside the ML community, especially at this exact moment. I will not say that. I will basically say Google. I think Google is fairly evil at this point. But as we'll discover, Colab is a really good tool. So it's like many other Google products. It's the best thing out there, so we kind of have to deal with it. And I'll talk about why I think that is, but just know it's Google. So if you have an extreme ethical stance against Google, you may want to look elsewhere for other tools. So Colab is essentially Linux-based GPUs. So the reason that we need to use Colab versus our own Macintosh computers or Windows is that we need access to a Linux defined GPU. The GPUs that are available through Colab start at about $5,000 to buy one, and they make them readily available to you for free or $10 a month. So it's a pretty powerful platform. Similar to how Google does everything, which is they make everything that is really powerful and expensive cheap, and in return for that, you give them lots of data. So Colab is based on this concept of Jupyter Notebooks. Jupyter Notebooks have preceded Colab. They've been popular probably for at least a decade, if not longer, and they're big within the data science community, and we'll see why in a minute, because it is sort of the concept of a notebook is basically an idea that you can run some code, you can also take notes in it, you can share that with other people. It's very much sort of like an educational tool in addition to being a powerful experience. But it is based, it's like a fork of Jupyter Notebooks, and other folks might tell you oh, I've got a Jupyter Notebook that you could use, and there's ways to port those into Colab. I won't cover that in this video, but there are ways to do that if you're interested. And the really important thing about Colab is that it's free-ish. So like any Google product, there's a free version, but there's also a version that's paid. It's called Colab Pro. I'll talk about that in a minute. The free version is pretty good, but I would recommend for folks taking my classes that you pay for Colab Pro, which is $10 a month and currently only available in the US and Canada, but I believe that will change pretty soon. And for those of you outside of those areas, you can usually get away with just installing it or paying for it if you use a US zip code and a credit card that works in the US. So again, I'll cover that in just a minute. So positives of Colab are that it's free, free-ish. What we're going to find is and I hope that you discover this as you go through the notebooks that Leah and I have created, is that they're really tutorials. They're tutorials plus running code, which is really nice and hopefully a way that you can sort of learn and read up on things while also running code in a command line style interface. The other nice thing is that most of the dependencies you're going to need for these things are already come pre-installed. One of the hardest parts about machine learning is that you have to install a ton of code, and that is just a really frustrating experience, especially if you're not comfortable using the command line. So Colab eliminates a lot of that, which is why it's great for this class, because honestly, if I were to teach how to install all these tools, it would be 1 week I'd teach you how to install stuff, and the next week I'd have to teach you how to run it. This eliminates a lot of the installation issues that we will run into. What's also nice is that you can assign a web URL or save a file to GitHub, and then I can share it freely with anyone. So you could also like make updates to a notebook, save it to your drive or save it to GitHub, and then share it with someone else, and they can pick up from there. So it's, again, sort of like the nice benefit of the web, and that you can share amongst colleagues and people on the internet. Downsides to Colab is there are some time limits. So the biggest downside between Colab and, say, renting your own machine learning server is that Colab has a pretty strict time limit. You can use it, if you're on regular Colab, it's 10 hours. If you're on Colab Pro, it's 20 hours. So basically, that's a continuous runtime you have. So you can run an entire script or other function for either 10 or 20 hours. After that point, your machine will be shut down, and you'll have to restart your machine. So you can restart a minute after it shuts down, but there's sort of a break there, which will cause some issues as we look at training. I've developed some ways to get around that, or like to work within those constraints, but it is kind of one of the annoying parts of Colab. And there are some GPU and CPU limits. Again, I would recommend Colab Pro for anyone in my classes because it kind of gets over some of this. So we'll get access to really nice GPUs. They won't be huge. They'll still be 16 gigabyte, which is a pretty general size, which will let us do StyleGAN and most of the major ML libraries. You could, there are other places you could rent a 4x GPU rig and do your training in, a week instead of like a month. But the cost will be far, far higher than Colab. So just be aware of that. And lastly, as I mentioned, this is a Google product, so take that however you will. What they're doing with our data that gets shared, I don't know. I doubt they're really doing that much with it. But Google is a big data company, and therefore they're probably doing something with your data and looking at something you're generating. So just be cautious about how you use Google and how you think about it. So I mentioned Colab Pro. Colab Pro is $10 a month. It is now, this is an out-of-date slide, is now available in US and Canada. I have a high likelihood that it will be expanded beyond that. But as I mentioned, if you have a credit card that works in one of those countries, you can find a zip code that also is in one of those countries, and they don't really check. So go ahead and do it. I don't think you're really breaking any laws. You're probably breaking our terms of service, but in my experience, they don't really care that much. They're happy to take your money. So Colab Pro does give you 20 hours of continuous runtime versus the 10, and there's a much higher chance you get a really, really good GPU called the V100. If you're on non-Colab Pro, I'm almost guaranteed you don't get one of these. This machine is pretty much like not necessarily the top of the line today, but it is one of the top of the line GPUs. It is very fast. For $10 a month, if you were to rent a V100 from, say, AWS or another website, you're probably paying $10 a day, if not more, to rent one of these. So getting one of these at $10 a month is a steal, and why I can't really recommend that we don't use Colab. The price and the functionality and all this makes Colab pretty much the best tool for people like me or people taking my classes. So we're kind of stuck with it until maybe a competitor comes up. Although maybe that competitor would be like a Facebook or someone. So who knows if we would get any better solution out of that. But highly recommend Colab Pro. I'll show you in class how to install or how to get this set up. But if you're just watching this video on YouTube, I highly recommend Colab Pro. So you probably already started playing with Runway a little bit because it's a nice way to get started. The big differences between Colab and Runway is obviously Colab's honestly much, much cheaper. After a while, if you do a lot of training in Runway, you'll start to realize it's a little pricey. Not really that pricey compared to, say, renting your own server, but since Colab has, the Google model of freemium, it is much cheaper. Second, Runway has a limitation of really only working with images. There's some ways around that with video and that sort of thing, but it's still really mostly image-based. Colab doesn't really care. Like, you upload stuff as audio or video files, you can do any types of ML or data science work within it. And Colab often gives you more control. Like Runway, for having a nice GUI, can also sort of limit you in terms of what you can and cannot do. So Colab will be a lot more free, and that's sort of why I think a lot of people quickly move on to Colab to play with it. The downside of that is there is no GUI, right? So if you are used to being a GUI person that plays with Photoshop or that sort of thing, having to see a bunch of code in cells can be really, it can feel daunting. And my recommendation is don't worry about what the code is, just try to run the cell, and then come back to it later. So I'll explain that a little bit more as we get into notebooks, but just be aware that this is a challenge, and I'm aware for many designers and artists that this is very frustrating, or adds a whole nother level of complexity. But hopefully if you take one of my classes, we can get you over that hump and make you feel more comfortable with it. Because it is also basically like closer to the metal, to say the least, with Colab. There are more errors. There is more need for debugging. I'll talk about my best approaches to that toward the end of this video, but just beware, there is some issue with this. And again, hopefully one of our classes will walk you through that. And so let's break down what Colab is. So Colab is a terminal interface. For those of you who haven't used a command line interface before, it's the thing that always shows up in hacker movies. But it's a terminal or a command line interface. It's a code editor. So if you've never edited code, most engineers or people using code use a code editor that looks like this, or something similar. And it's also a note-taking interface. So this is what's pretty cool about it, is it also allows you to use Markdown and other text to be able to really mark up and document what you're doing. And of course, the really important thing for us is that it also adds a GPU. So this is a V100, probably not the V100 that's exactly in one of these machines, but this is a V100, and it is, again, like I said, this is probably about an $8,000 GPU if you were to try to buy one yourself. So, we'll get that for $10 a month. So this is a really, really powerful interface, but it also is this is where people get tripped up, is they try to think of it as just this, or this feels confusing in the context of all this. But just remember that each of these pieces is important, but you can also break it down into these sections and sort of start to parse out the individual pieces. So, for example, if you've never run Python code before, what you usually have to do is you have to write a bunch of code in a code editor, and then you have to come over to the command line interface and actually run this script. So let's say this script is called example py. You actually have to go into the command line and say Python example py. If you're used to just coding for the web or like in an HTML or JavaScript interface, the web sort of like obfuscates a lot of this stuff because all you have to do is refresh your browser. But behind the scenes in a lot of tools, there are these scripts that get run. So this is actually the first thing that happens within Colab, is you kind of combine these two pieces into one thing. So for example, like you could just take all of this code that you wrote in a code editor and dump it into Colab, and this would work just fine. Like this is a totally workable way to use Colab. Like you run the cell, we'll look at how to run the cell in just a minute, but you go ahead and hit play and you run this, and like you run all the code. Like you could do that. That's totally fine. And usually when I start making notebooks, that is how I start. But it's not ideal. It's not really the way that Colab wants to work. So the first thing that I tend to do is like I'll dump in all my code and I'll start to break things up into cells. And the important thing to know here is that these gray boxes here, these are what we call cells. You can run these like code again. So if we come back here and we sort of see like, okay, here's this command, here's a bunch of variables we're setting, and you break those out into individual things. And then what I'll do is I'll add a bunch of documentation, right? So I'll sort of say like, okay, here are the variables that we're setting, here's what each of them does, and then you can go in and actually edit them and set them. So this is a really helpful way to, again, hopefully make code a little bit cleaner for people who are not used to reading code, or even if you are used to reading code, like, it's nice to have some high level, like, markup or design to the page, right? So assigning H1s or H2s, being able to add bulleted lists, being able to like, highlight code snippets, or, being able to add bold. You might be used to just seeing it all in commented out sections, and like, that's fine, but like clearly it'd be nice if we could do this, right, in other places. So this is something that Colab makes available to us. And then the last thing that we sort of know is like, there's this challenge here of where you'll see me doing this thing from OpenSimplex, import OpenSimplex. There's a library. You don't need to really worry about that just yet, but basically like installing libraries through Python isn't really possible. What we do in reality is we actually install these libraries using the command line interface and then bring them into the editor. So again, if you're used to doing stuff on the web, you probably don't really experience this because some of it is all done behind the scenes or you're not aware of it. But if you've done Python or other development in a code editor with a command line, like there's just a lot of work to do bouncing between multiple applications. And Colab actually does all that in one interface. So when you look at a code cell and it's got either a I just want to say interrobang, which is actually what that is, but an exclamation mark or a % sign, that usually means what we're actually doing is running a command line command. And you can't do this in a traditional code editor, right? There's no way to say, okay, do this in the command line, but then do this in the Python interpreter. But Colab does this. It makes it possible to sort of mix and match these things, which can also lead to some confusion because in some cases you'll even write some Python and then include a command line command from there, and the interpreter is able to make all that work. But if you're used to just writing code, this is kind of a new way for you to see things. So just know that if you see something that starts with an exclamation point or a percentage sign, that usually means that we're actually doing a command line command. And then everything else is in Python, right? So the rest of this is written in Python. Colab pretty much only supports Python. Most machine learning and data science work is done in Python. There are some newer libraries available to you, but most of it's in Python. And if you haven't used Python before, it can be a little frustrating because white space is important. So you don't use brackets, you mostly use tabs and indentations. For my classes, you usually don't need to write Python at all, ever. But if you are interested in reading some of the code and you're not used to it, I would definitely recommend checking out maybe a Python tutorial before getting started. So all to say, like, this is all very powerful, but it's confusing. So the first week or two that you're going to try this is going to be very frustrating. But I promise you that after a while, you'll sort of be like, I wish I could just do this everywhere, right? Like running multiple applications from my desktop is kind of annoying, and being able to do it all in one in Colab or a Jupyter Notebook is actually very helpful. So bear with the frustration and the confusion. Like, it's like I don't say it's like riding a bike. That's the wrong metaphor, but it takes a little bit of time just to get set up and get comfortable with it. But once you do, I think you'll find it's pretty helpful and powerful. So a couple other notes here. Everyone writes notebooks in different ways. And this will make finding other people's notebooks kind of a challenge. So this is an example. This is the Deep Dream notebook. And you'll just see there's a lot of raw code here in every cell, right? Like there's imports, there's a bunch of if-else statements. So for those of you who are not comfortable reading code, this can feel really daunting. You're sort of like, what's going on here? Like, what do I do? How do I work with this? There's also some light GUI things you can build into Colab. We might discuss those in a class like this. We might not. But just know these are possible, and these are things that some people have built in to try to make it a little bit easier to use. I don't know if it actually does. I'm sort of on the fence about it. But essentially, like, these are other things you can have. So it can just start to feel like it's a very complicated interface. What I would recommend is break things down into each piece. What am I trying to do? What do I think is happening here? How do I break this down into like manageable pieces? So I'm not like, if you first open one of these notebooks for the first time, you scroll through it, you're like, oh my God, there's so much here. I don't know what to do with this. And that's totally understandable. And I would just recommend walking through it one cell at a time. This is how I write my notebooks. So my notebooks are really built more for our classes. And the way that I will do stuff is I'll just have a series of variables that you'll set at the very top of the cell. And then we run a script at the bottom of the cell that actually like uses all those variables. The plus side of this is I hope, or I think it's a little bit cleaner. The downside of this is that if you are interested in reading the code, all of this is sort of obfuscated away into a script file, into a Python file that you have to find in your Colab interface. So it's not the easiest thing. It just depends for different different strokes for different folks. Most people will write their code like this. It makes sense if you are familiar with machine learning code and you want to be able to access it or tweak things. But for my classes, I tend to write it like this because I think it's a little bit easier to understand, and it's less like overwhelming code everywhere. So let's just take a look at a really quick basics, a notebook. I just want to walk you through how the Colab interface works. So the first thing you'll notice is when you come to the screen like this, you'll sort of just see there's a lot of text here. There is code cells, which these are in gray backgrounds, and then the text cells are more like this. You can format this. I have to say, like, I don't love some of the design of Google interfaces, and I think some of this text could be a little bit hard to read, but such is life. I wish they had a shorter line length, that sort of thing, but so it goes. So let's talk a little bit about the interface here. So along the left-hand side, you've got a table of contents, which basically allows, you can sort of like see how indentations work. So it's H1, H2, H3. It sort of breaks down, and you can jump around, which is a nice thing to do in some of these longer notebooks. It allows you to sort of see these different pieces. Second is a search. I pretty much never use the search, but if you do need to find and replace something, you can use that. Third thing is a code snippets section. I use a lot of code snippets because I never remember anything about code. I'm constantly Googling, like, how does this work? How do I do this? So I tend to save a lot of snippets so that I can easily access them. I have a different video on how to install snippets. If you're interested in that, I'll link to that. But I definitely use a lot of snippets. I think, again, many people expect you to know how to write code and memorize everything. I'm not that type of person. I Google everything. And if I Google something enough, I will just write it down and add it as a snippet. So just be aware those exist. And then lastly, we've got our file interface. So the first thing you'll notice here is that because we're not connected to a runtime, or we weren't at that second, we didn't have anything here. Over here, there was that connect button. And when you connected, it actually showed you what your files are. So if you come to an interface or come to a Colab notebook for the very first time, and it looks like this, so you see there, this will actually say connect, not reconnect. One of the first things you want to do is just hit connect. This is going to connect you to a server. It's going to assign you a GPU if your file is set up to access a GPU. I don't believe this one is actually from the very beginning. Let me see. Yeah, so you'll see hardware accelerator, none. So we'll set it to GPU at one point. This is where, if for whatever reason you're having issues with the GPU, this is probably where you want to go to runtime, change runtime type, GPU, and we'll hit save. So how do you run a cell? So there's two ways to run a code cell. The first is you can hit the little play button here. So when you hit play, it's going to give you a message because this is hosted on GitHub. Just say run anyway. And it will spit out this code into what's called the console. That is the part below the cell. So this is a pretty simple command. It just is like it prints this text to the console. But you can also set variables. So again, I don't know how everyone is with code or that sort of thing, but there are variables you can set. So this is setting a variable called first number to 12 and a variable called second number to 25. So the second way you can run this is to click into the cell and then hit shift return. And you'll see that not much happened here because I wasn't printing anything to the console. So it just kind of ran and then it just stopped. One thing to notice is that you've got these little numbers here. So see how this cell up here has a 1 and this cell here has a 3? The numbering denotes the order in which you run cells. One of the kind of confusing things about Colab or just notebooks in general is that the order in which you run these cells matters. And you can get kind of lost some days, like trying to figure out where things went wrong. And it could be that a certain cell you skipped or a certain cell was run out of order, those sort of things. I generally recommend you run top to bottom the very first time you use a notebook and then come back. So we're going to take these variables. The other thing to remember is that as we run these cells, each of them gets saved into our runtime. So we've now saved these variables into our runtime. And when we come down here, we're actually going to use these variables to do some math and print out the answers. So we're going to run this cell using shift return. And you'll see it ran 12 plus 25 equals 37. So again, if you're not used to Python, this is looks maybe complicated, but all we're saying is, use this variable and this variable and then add the two together. So what's kind of cool about this is that this cell can run independently of this cell, right? So let's say that or another cell can actually edit the overall runtime variables. So let's say that I want to run this cell. So this is going to change the second number variable to 30 instead of 25. So I'm going to run this. So now I've updated the second number variable, but the first number variable remains the same. So if I come back here and I run this cell, I've now run a cell below it, but I'm actually going to run it again. And this is now going to say 12 plus 30 equals 42. So this is powerful in that you can start to edit things in different places and then move around, but it's also confusing. So what I really recommend is going through a notebook slowly, trying to ascertain exactly the order in which you're running things and then come back to it. So I'll do another demo with this, to talk about more about this notebook, but those are the big things I want to highlight. It's just that, take it slow. It's your first time doing anything. If it were your first time painting, you wouldn't try to, paint the most amazing portrait in the world. You would just try to understand how it works and work your way up to it. So just be aware of that. Okay, so a couple other things I want to talk about. How to deal with errors. Errors are extremely common in machine learning tools. Notebooks go out of date almost overnight. Other things happen. So you will come up with errors. My number one answer for you is you don't need to know how to read the code immediately or maybe ever. Even in notebooks that I look at today, I'm not often reading the code that frequently, or even definitely at the beginning, I'm not. So my way to approach this is first, let's start by just trying to read the code. or sorry, skip trying to read the code. Just run the cells. So run each cell in order. And if you get errors, try solving those errors before you go on. So Google Foo is like kind of like a whole skill for engineering or people writing code. Usually what I do is I take the error message and I will paste it into Google and I'll try to find an answer. That again is a skill that's learned. It is not something that happens overnight. But go ahead and try it. Like just see if you can find a result or maybe an answer. Then go back and try to keep the notebook running. So basically, if you can run the notebook from top to bottom without any errors, that's the first key thing you want to do. Then you want to go back and maybe try to figure out what the variables are, or maybe tweak some things. Try running that, and then maybe if you're really interested in learning the code, then after that, do you want to try to learn the code? So you might want to Google function names or variable names or library names to try to understand that. Quite honestly, half the time I skip this step and I just understand how it works, and that's all I need to know. I don't need to know how they built it or whatever it is. But I know for many people who are get into this, the first thing they want to do is try to understand the code. And I'll say machine learning code is actually kind of hard to read. So I would almost recommend you don't do that initially. Like I know you're going to want to. I know many of us want to understand everything that's happening. And sometimes we don't need to. Sometimes we just want to make sure the thing works and does something cool before investing heavily into that. So most of the notebooks that I will write in my classes, hopefully, knock on wood, do not have errors. Leah and I will hopefully have tested them before class. But every once in a while something sneaks in, or every once in a while we'll just share a notebook randomly, and you might run into errors, or they might have other issues with them. So my recommendation is sort of first off, make sure it's an error. A lot of times you'll get a piece of red text and it'll say warning, etc. Those are warnings, not errors. It's fine. Everyone makes mistakes because they see the red and they're like, oh my God, something's wrong. Next, try to Google the error. So again, just try to figure out what the variables that you might want to remove are to get the right message, to get the right solution on either Stack Overflow or other places on the internet. Spend 5 to 10 minutes of that. Just try it. Part of it is just understanding how to filter out good results from bad results and maybe seeing what works. Again, it's frustrating for a lot of people who are new to it, but it's a good thing to start to get in the habit of doing. And lastly, I would say if after 5 minutes you have no idea what you're doing, just drop a note in our Slack channel, either message me or Leah, and one of us can help debug things a lot easier, because we've probably seen most of the error messages that you're going to see. So if you're in my class, please just do that. You're not burdening me. Our job is to help you, so make sure that you ask for that help. So that's pretty much it for dealing with errors. This is, again, a dark art and a thing you'll have to learn over time. So this was a really long video, but this is just to get you started in working with Colab. We will do a lot of other Colab demos throughout the class. We will also, upload demos. Leah and I tend to, demo other notebooks, and we'll walk you through other notebooks. And hopefully all of that will get you really comfortable with Colab. So just to reiterate, this is a hard thing to do. I don't expect anyone to be able to do it overnight. The first week of using Colab will probably be very, very frustrating, and you will hate me. And I promise that we will get through it together. We will be able to, start to use notebooks in really powerful ways, and we'll find them really powerful and efficient and cheap. And that's really what we want to sort of get out of this, is that it's a tool that's only slightly more expensive than free, and allows us to do a lot of things. So we'll probably be focusing a lot on Colab in these classes, and also in my video series. So the more familiar, the more comfortable you are with Colab, the more likely you are to be able to get to some of those newer things. Because another great thing about sort of machine learning is that I think a lot of people are moving to Colab as a demo interface. So if someone releases a new piece of code, a lot of times they also release a Colab notebook with it. So if you can run that notebook, that saves you a lot of time than trying to set stuff up on a server somewhere. So Colab's really powerful. I think it's a really cool tool. I think it's really helpful, but it's also a learning curve. So this is your first step. Lee and I are here to support you. But so hopefully this helped you understand a little bit more about how Colab works, and over the next couple weeks you'll begin to feel more comfortable using it. So with that, that's it for this video. Thank you so much, and hope to see you in class soon.